Hello everyone, in this session we are going to study the simply supported beam with uniformly varying load. Right? Suppose we have simply supported beam. This is our simply supported beam. One is hinge joint, another is roller joint, as you already know. And there is a UVL. It has maximum, say we are taking one of the case that it is maximum at the one end and zero at the other end. So it is 0 at the other end. So this is end A, this is B, and UVL is decreasing from maximum to 0 from one end to another, like this, right? And it has W kilonewton per meter of intensity of load at one end, maximum end, and 0 intensity at the other end, right? And we have to find out the shear force and bending moment diagram for this case. Now, suppose the length of this beam is L, length of this beam is given L, right? As you already know that in case of a triangular like this triangle, the centroid will be acting at h by 3 or L by 3 here, because we are taking L here, L by 3 from the base or 2L by 3 from the apex, and the value will be the area of the triangle, right? So what will be the total force concentrated at centroid, at certain centroid? Suppose this is our centroid, there will be a load, total load will be concentrated at this point, and the value will be half base into height. Height is W, base is L, half WL, so WL by 2, half multiplied by base multiplied by height, so this is WL by 2. This much force is acting at the centroid, and centroid lies at the distance L by 3 from the base and 2L by 3 from the apex. So this is our height, suppose this is L by 3. So this distance will be L by 3 and other distance will be 2L by 3, right? This distance will be 2L by 3 from the apex point B, right? And we have to find out first the reaction. Suppose this is the reaction at point A, we are saying RA, and this is the reaction at point B, we are saying it RB. So RA and RB are the reaction at A and B, right? And it is not symmetric, it is higher at this reaction and the load will be lower at this reaction, seeing the figure, right? So how to find out first the reactions? For finding the reactions, you have to take the moment about certain point. Let us take the moment about point A. So take moment about say one point A, right? And sum of all the moments about A should be equal to 0, because it is a hinge joint, and at hinge joint the sum of the moments about A will be equal to 0. So we have how many forces are there? Three forces are there: RA, WL by 2 and RB. RA is passing through A, so it is not having any movement because the perpendicular distance will be equal to 0. So it will be omitted. WL by 2 will be having a movement, WL by 2 multiplied by L by 3, because perpendicular distance is L by 3. So moment of WL by 2 will be equal to WL by 2 multiplied by perpendicular distance, that is L by 3. And let us take it positive, then RB will be negative. So minus RB multiplied by the perpendicular distance, that is L. So that is L. So by this you will be able to find out RB, and that will be equal to WL by 6. WL by 6. So this is a reaction at point B, right? So remember this is a reaction. Now we want to find out RA. How to find out RA? RA can be found out by taking the vertical forces. The sum of all the vertical forces should be equal to 0 for static equilibrium, right? So for static equilibrium, sum of the forces in vertical direction should be equal to 0. This will be equal to, this implies the downward forces and upward forces should be equal to 0. So downward force is WL by 2. Let us take it positive. Upward force is RA. Another upward force is RB. So that should be equal to 0. So put the value of RB from here, WL by 6, and RA is here. So there will be one unknown only, RA. So you will get RA from here by putting the value of RB here, right? And you will get the value of RA as WL by 3. So you will get the value of RA as WL by 3. So we have found out RA and RB, both the reactions are available to us now. Now we want to find out shear force. Shear force. So how can we find out shear force? For finding the shear force, let us take any section either on the left or to the right of the section. It is up to you. So it will be better to take the section from the right, because this is a triangle, single triangle in that case. So let us take a cross section x cross section at this from this point, right? And this will be the load intensity at a distance x from the point B. We are taking the reference point from B, we are taking at a distance x. This much is the load, right? And how much it is load? So this is the case, I am making this case here, that this is the triangle, this is the triangle at a distance x. This is the load, this is the load acting on this, and the load will be acting at certain point which is at centroid of this triangle, small triangle, and the triangle name is bx, suppose x dash. So bx x dash, this is this triangle I have made here, right? So bx x dash is the triangle, and what is the load acting on this? So in the length of L, the load is W. What is the load at a distance x, right? Unitary method can be applied as we have done earlier. So this will be W by L multiplied by x. So load here will be WL by x, Wx by L, Wx by L. In the length of L, the load is W. So in the length of x, what will be the load? So Wx by L, and the distance is x, and the distance is x. This distance total is x. Then what will be the intensity of this load? Intensity of this load will be half multiplied by base multiplied by height, because area of the triangle. So half base and height. So half multiplied by base, so it will be Wx square by 2L. So it will be Wx square by 2L, area of this triangle. Area of this triangle will be the load intensity acting downward, and at a distance of x by 3 from x dash. So this distance will be x by 3 from x dash, right? So at a distance of x by x dash 3, x by 3, a load intensity is taking place, which is Wx square by 2L. So here Wx square by 2L is the load acting. Wx square by 2L is a load acting here, Wx square by 2L, at a distance of x by 3 from this side, right? And the total distance of this is x. This distance is x, like this. So now we can see here that the load acting at this point is Wx square by 2L at a distance x by 3. Now we can find out the shear force. And what is shear force? What is shear force? It is the sum of all the forces to the left or to the right of the section, algebraic sum of them, right? So we are taking rightward to this cross section x, we are taking the rightward direction. In rightward direction there are two forces. One is RB, another is Wx square by 2L. So RB is in upward direction. So in upward direction on right side, right side, the force is negative, shear force is negative, and downward direction on right side the force is positive. So RB will be taken as negative and Wx square by 2L will be taken as positive, right? So let us take the shear force at distance x. So shear force Fx, that will be equal to RB negative and this is positive. So Wx square by 2L is positive because it is rightward downward. Rightward downward is positive, and minus RB, and the value of RB is 2 WL by 6, WL by 6. So this is the shear force. This is the shear force and it is valid from B to A. Valid from B to A, right? So it will be valid from B to A. So this is the shear force, right? And it is parabolic. You can see here this is parabolic in nature. And what are the shear forces at A and B at endpoints, so that we can draw the diagram. And it is parabolic. We know that this is parabolic, right? So let us draw find out FB. FB will be equal to, at FB x is 0. Put x is equal to 0, you will get minus WL by 6 at x equal to 0. And find out FA, that will be equal to x. Now x become L. So this will be WL square by 2L. Put the value of here WL square. Put x is equal to L here and find out the value. What you will get? So you will get WL by 3. WL by 3, positive value, WL by 3. Solve it and you will get the value at x equal to L. Put x is equal to L in this equation and you will get these values, FB and FA. You see here, FA is greater than FB. FA is greater than FB, and it is obvious because the reaction is higher here, the load is higher here. That's why shear force is higher at point A and shear force is lower at point B. And it is positive and it is negative. So you can draw the diagram now. This is WL by 3 at FA. So at FA, the value is WL by 3. Suppose this much value is the on scale. This much value is WL by 3. And at FB, this is WL by 6. So this is WL by 6. This much value, right? So WL by 6, isn't it? So this is WL by 3 and this is half of that, WL by 6, and it is negative, right? WL by 6 is negative, WL by 3 is positive. And the curve is parabolic. X square term is there, parabolic. So you can make it a parabola like this, right? You will get the shear force 0 at certain point. We are not able to judge where this point is there. It is not at the center. It is not at center. It will not be happening at center, right? So it will be at another point, right? And this is our A, this is B, and this is shear force at certain point C, and this value is the maximum value, WL by 3, and this value is the negative value at lower end, right? So this is the shear force diagram. Shear force diagram, parabolic diagram, right? Because here it is x square, it is parabolic. So at point C, shear force is 0, and as you know that the point where shear force is 0, the bending moment will be maximum. So you will get the maximum bending moment at this point, and it is not at center. It is not at center. So bending moment will be maximum at point C. Now draw the bending moment diagram. Bending moment diagram. How to draw the bending moment diagram? So similarly, you can take a line AB, which is our beam, and we know that at this point there will be a maxima of the bending moment will obtain, right? At this point C. This is not at center, this is at certain point C in between A and B, right? So how to find out bending moment? So bending moment will be, what is bending moment? Bending moment is the movement of all the forces to the left or to the right of the section. So we have taken this section at a distance x from B. So to the right of this section there are two forces, RB and Wx square by 2L. So it will be having moment. So Wx square by 2L has distance x by 3 and RB has distance x. And RB is upward, so it is making anti-clockwise couple. So anti-clockwise couple is positive and Wx square by 2L is negative, right? So we can write out bending moment at point x will be equal to RB is positive, so RB multiplied by x, RB is WL by 6, so WLx by 6, RB multiplied by x, and this is positive moment of RB and this is positive, this is sagging bending moment, and Wx square by 2L is making hogging bending moment, right? This type of bending moment, right? Clockwise on the right. So it is x by 3 distance. So we will write this will be equal to minus, because it is negative, Wx cube by 6L. Wx cube by 6L. So this is the equation for bending moment. This is the equation for bending moment at x. Wx cube by 6L and WLx by 6, right? So this is the bending moment and it is valid. It is valid between, suppose this is equation number 1, this was equation number 1, which is valid from B to A, and this is equation number 2. This is again valid from B to A because there is no other force in between other than UVL, right? So this is the force, the moment. So what is bending moment at point A? At point A, x will be equal to L. So put x is equal to L here. So WL square by 6, it will be 0. So you will get 0 at x equal to L. And find out MB. At MB, x is equal to 0. Put x is equal to 0 here, you will again get 0. This is at x is equal to 0. So we have obtained the bending moment at point A and point B. At point A, the bending moment is 0. At point B, the bending moment is 0. And it is changing at a cubic parabola. X cube is there, cubic parabola will be there, and it will be maximum at point this, because the shear force is 0 at certain point, right? So you will get this type of curve. You will get some maxima and then it will decrease, right? So first of all it will increase to get the maxima and then it will decrease, and this is the maximum bending moment. This is the maximum bending moment, Mmax, maximum bending moment at certain point C. It is not at center, right? So where this bending moment is maximum, or what is the point where shear force is 0? So where shear force is 0, we know this equation. If we put Fx equal to 0, we will get the value of x where shear force will be equal to 0. So put Fx equal to 0, shear force equal to 0, so we will get C point. Then we will get Fx equal to 0, you will get Wx square by 2L minus WL by 6 equal to 0, right? Solve it and you will get the value of x. You will get the value of x at which the shear force will be equal to 0. Solve it and try it. You will get x will be equal to L by root 3, right? So you will get the value of x as L by root 3. So at x is equal to L by root 3, shear force will be equal to 0 and bending moment will be maximum. So this point L is equal to root 3 is a point of maximum bending moment and point of 0 shear force. So 0 shear force and maximum bending moment. So this distance is L by root 3 basically. This distance is from L by root 3 from where? We are taking x from the B. So from B, this distance is L by root 3, where the shear force is 0 and bending moment is maximum, L by root 3, right? So this is the case of simply supported beam. So L by root 3 is that point where shear force is 0 and bending moment is maximum. So we have written L by root 3 because x was taken from the point B. So x will come out to be L by root 3. We have put here L by root 3 from B to C. So BC is the distance of the maximum bending moment, or where shear force is 0, right? Now we want to find out the maximum value of bending moment. What is the maximum value of bending moment? If we put L by root 3, x is equal to L by root 3 in this equation 2, whatever bending moment will come, that will be the maximum bending moment, because this x is equal to L by root 3 is the point of maximum bending moment. So put x equal to L by root 3 in equation number 2 to get maximum bending moment, right? So put that value here, x is equal to L by root 3, put here and you will get the answer. So what is mx? That will be equal to WL by 6 into x is L by root 3, minus W by 6L multiply x cube is L by root 3 cube. So by this you will get the maximum value of bending moment, mmax, and the maximum bending moment you will get WL square by 9 root 3. Solve this and you will get this answer. Solve this, WL square by 9 root 3, right? Solve it and you will get this answer, right? WL square by 9 root 3. It means that this maximum bending moment is given by WL square by 9 root 3. So this is our maximum bending moment. So by this we can draw the shear force diagram and bending moment diagram. We can also find out the point where shear force is changing its sign, that is the shear force is 0, that is C point. We have obtained that by putting the shear force equal to 0 and find out the value of x. Also we can find out the maximum bending moment, because maximum bending moment point is very important. Maximum bending stresses will be acting at this point only, right? And this is the point, this may be the point of failure. So that's why it is very important point. And what is that value of maximum bending moment? So we can obtain by putting x is equal to L by root 3 in this equation of bending moment, and whatever bending moment we will get, that will be the maximum bending moment. So this is the case of simply supported beam with UVL. Okay, thank you.